Hello everyone. Those who are live and online for the session, please say hi in the chat window so that we can start. Hi Priyanka, Neha, Samiksha, Nisha, Abdullah. Hello everyone. Hi Pratibha. So in this session we will be discussing about something called as grammars. तो हम लोग grammars के बारे में discuss करेंगे and we'll be having two sessions here. The first session will be the basics of grammar and second sessions will be the operations that we can perform on grammars. तो जो आपका पहला session है right now, for example, this is your first session here. So in this session we'll be discussing about what is grammar. So that is the basics of grammar कि grammars होती क्या है and how can you create grammars for some of the languages. We'll take some examples like 15 to 20 examples and then I guess we will be moving on to other things. Okay, so hi Dhanya. So it is 3:18 right now, 3:18 हुए हैं. So we will start the class at 3:20. 3:20 पर हम अपनी क्लास को कंटिन्यू करेंगे. So I hope that everyone is available for the session. Everyone is present, so we can start, I guess. जल्दी से जो students online हैं, those who are online, again say hi in the chat window so that I can start. I should know how many of you are present. It is 8:20, so I think there are 7 to 8 students are present. Please say hi again. Pratibha, everyone, please say hi again so that I should know your names. Those who are present right now, I can start accordingly. So hi Pratibha, Samiksha, Neha, Priyanka. Okay, cool. So I guess we can start now. Fine. So here we are discussing about grammars. So things that we'll be discussing in today's session. So first of all, we'll be discussing about what is the basics. That is, what is grammar? What is a grammar? Then we will be taking some examples of grammars. And then at the third we'll be discussing about what are the types of grammar. Types of grammars. There are different criteria. On the basis of these criteria we can define what are the different types of grammar. And the fourth one, again we will take some more examples. So these are the four things that we'll be covering in this first session. जो आपका जो first session है, यहाँ पर हम लोग ये 4 चीजें कवर करने वाले हैं. Now the first thing is, what is a grammar? Grammar होती क्या है? What is a grammar? So if you see in any of the languages, whether you are studying English language, whether you are studying Hindi language, आप अगर कोई भी language को study कर रहे हैं, so in any of the languages, Grammar means something that gives a rule that how can you connect different words to make proper sentences. So the rules to create sentences, the rules to create speeches, those rules are defined in a grammar. Okay, so if I say the example of English language, right? You have an English language. Now in English language, in a grammar of English language, see, I'm not very good with the English language. I do not really know the proper English grammar also. I make a lot of mistakes in English. So if I make mistakes here, please do not judge, okay, because I'm very bad at English. Okay, so I learned my English from watching the movies. I was very bad in English, so what I used to do is in 11th and 12th class I started watching Hollywood movies, and I started reading the subtitles of those movies. I never learned a proper way of communicating in English, so I do not really have any good knowledge about grammar, so I'm zero about it. Okay, so in English, when you have a grammar, so here whenever you create a sentence can be created using a noun phrase as well as a verb phrase. So we have two things in a sentence. We have a noun as well as a verb. So for example, if I discuss about a noun, so noun can be divided into further two parts. One is your article and the noun phrase, right? For example, the student, a student or something like this, right? So but simply if I just want to make very simple sentence, I mean 2-word sentences, I can make 2-word sentences just like this. I can say noun as, let us suppose it is a name. So we have a name like Pratibha. Pratibha is a name, so it is a noun. So we have a name here which is Priyanka. We have a name here which is Neha, right? So these names are basically a nouns, correct? Further we have a verbs. Verbs are the actions that these nouns produce. So for example, they can run, they can sing, they can walk, they can talk, or anything, right? So we can have like writes or something, goes, something like these are the verbs. So in this entire sentence, when I look at this grammar, I'll be able to make sentences from this, right? So I can say, if I want to make sentences, I can say a sentence can be created by a noun as well as a verb. I can replace this noun by any one of them. I can say the noun is Pratibha, and then we have a verb, and then I can replace this verb by any one of them. So let us suppose it is sings, so it is Pratibha sings. Okay, so this is your proper sentence. This is your proper sentence. Okay, and how you created this sentence? You have created this sentence using this grammar. And it is a very simple grammar, because this is a grammar which is only producing 2-word sentences. So यहाँ पर जो भी sentences है आपके पास, all of these sentences are 2-word sentences. Fine. So you can clearly see how easy it is to create sentences if you know the grammars. Further, you can easily make these grammars more complicated. You can say even this noun can be divided into a noun phrase as well as an article, and further this verb can be divided into some like verb phrase and something, right? So further their branches are also possible. Now in this complete case, if you look at this sentence, this noun, this verb, these are basically your variables. And when I say Pratibha, Priyanka, Neha, run, sing, walk, right, these are your terminals. So variables is something just like in mathematics, you take a variable x, right? So you can say x is a variable which can assume any value. So in the same way, this noun can assume any of the 3 values. And then when we take exact value, which is 5, so why 5 is a terminal value. That means you cannot replace 5 by anything else. There is no other meaning. In the same way, these are your terminal values. So if I say whenever we have a grammar, so a grammar is created using 4 tuples, which is V, T, P, S, where V is the set of variables. How many variables are there? Sentence, noun, verb. These are 3 variables. In this entire grammar, the grammar that I have given you in this example, this grammar is having 3 variables, which is sentence, verb and noun. Then we have terminals. How many terminals are there? In this grammar we have 7 terminals, which is Priyanka, Pratibha, Neha, runs, sings, walks, writes. So here total of 7 terminals are there. Then P is a set of production rules. So production rules is the rules. Using these rules you can create sentences. For example, here all these 3 are your production rules. All these 3 are your production rules, and S is the start symbol. Okay, so let me just write all of these things again. So V is set of variables, B represents the set of variables, T represents the set of terminals, P represents the set of production rules, and S represents your start symbol. S represents your start symbol. So you can clearly see what is all of them, right? So here you can see V is a set, T is a set, P is a set, as well as S is also a set. So we can have only one start symbol. So start symbol means कि किस symbol से आप sentences को बनाना start करेंगे, right? For example, here S, this sentence is a start symbol. So you can start whenever you want to create a sentence, you want to start with this one. So because this is the starting point, and then you can derive more sentences based on this. Okay? So is this much clear? So again I am saying grammar is VTPS, which is set of variables. So how many variables are there? Sentence, noun and verb. There are 3 variables. Set of terminals. How many terminals are there? Pratibha, Priyanka, Neha, runs, sings, walks and writes. There are 7 terminals. P is a set of production rules. I mean the rules using which you can create sentences. And here we have 3 production rules, right? So actually these production rules are not just 3, these are more. But just for simplicity purpose, let me just say right now that these are 3 production rules. But again, you can consider noun derives Pratibha is 1 production rule, noun derives Priyanka is 1 production rule, and noun derives Neha is 1 production rule. But right now just keep it simple and just say that we have all of these are your production rules. Using these rules you will be able to create sentences. And then we have S. S represents the start symbol, that is from which symbol we can start so that we can make sentences. Itna clear hai? I hope this much is clear with all of you. Now here we create these sentences. Now there are 2 ways of creating these sentences. One is your sentential form. So for example, here this is your sentential form, as well as you can also create sentences using your tree forms. Okay, so for example, I can say a sentence can be created using a noun as well as a verb. Further, this noun can be any one of them. So let us suppose this noun is Priyanka, and let us suppose this verb can be any one of them. So let us say it is runs. So runs is a verb. So here you can see this form. If you create sentences using this form, this is called as your tree form. It is called as your tree form. Okay. So there are 2 ways of creating sentences. I mean there are 2 ways of creating this terminal string. So this will be called as your string, which is your terminal string. Okay. So in this case you will see that there are multiple ways how you can create this sentential form. You have a leftmost derivation, you have something called as rightmost derivation, which is LMD. We have RMD. In the same way you have leftmost, the tree which is skewed in the left direction, the tree which is skewed in the right direction. We will discuss about them later on. So first of all, let me take more examples here, more examples of a grammar, then you will understand. So we'll go step by step. Okay. So just write it down and then we will rub it up. So इसको लिख लीजिए अपनी notebook में. After writing it out, write down in the chat window. I'll take more examples of grammars. Okay. Good. Sure, I will answer all of your questions, Manpreet and Shivi and Kala and everyone. So just go through this. So let me just go through the lecture first, and then I'll answer all of your questions after in the end of the class. Okay. Okay, let me first take one more example of a grammar, and then I'll tell you how to create grammars, right? So let us suppose we have the language is, okay, so let me give you the grammar and then we can try and identify what the language is. So the grammar is S derive A S B slash AB. So this is your grammar, right? So it's a very simple as well as a small grammar. Now in this grammar, what are the set of variables? We have only one variable, which is S. In this grammar, what are the set of terminals? We have only two terminals here, which is A and B. And this is your production rule. So we have two production rules here. One is S can derive ASB, and second production rule is S can derive AB. So basically when I say slash, what does it mean? It means the same thing can also be presented like this. S can derive A, S, B, and S can derive AB. So instead of writing it in two different lines, because both the things S is driving, right? So instead of writing it in two different lines, what I do is I write them in the same line just by putting a dash. ठीक है, तो हम सिर्फ dash put करके हम लोग इसको एक ही लाइन में यहाँ पर लिख देते हैं. Now if you see in this grammar, as I said, in the grammar we have V, T, P and S. So what are the set of variables here? Only one variable is there, which is capital S. T is a set of terminals. How many terminals are there? We have two terminals, which is A and B. So these terminals are basically representing your input symbols. So just like summation, so this is also representing that same summation. Then we have P. P is representing the production rule. So here we have these two production rules. And then we have S, which is the start symbol. And here I'm having only S, and this is acting as a start symbol. Now if I try and create strings from this, how can you create strings? You can create S can derive AB. So this can be one string, S can directly derive AB. This is a terminal string, right? So that means the language created by this grammar can have the string which is AB. A part of this S can derive A capital SB. Further, this S can be replaced by AB. So it can be AA BB. So that means this grammar can also generate a string which is AA double B. In the same way, I can say S can derive A capital SB. Further, this S can be replaced by this same A capital SB. So this is A S B B, and further this S can be replaced by AB. So it is A B B B. So we will be able to create a string which is AAA and triple B. In the same way, I will also be able to create the string which is 4 times A and 4 times B. Okay, so basically you can notice here that we are using this definition of S in a recursive fashion. So recursively हम S की definition को use कर रहे हैं. So recursively we are using the definition of S, right? So wherever you have S, you can put the same definition again. Wherever we have S, you can put the same definition again. So just like this. So S can derive capital A, capital SB. Further, this S can be replaced by ASB only, right? So this is S can be replaced by ASB. So this is A S B B. Further, this S can be replaced by ASB. So it is again A S B B and B. Further, this S can also be replaced by this AB. So this will be A B B B B. So your string here that it is generating is 4 times A and 4 times B. So in fact, this grammar here is generating a language which is A raised to power n, B raised to power n, such that n is greater than or equal to 1. So the strings that will be generated from this grammar will be of the form which is A raised to power n, B raised to power n, such that n is greater than or equal to 1. So we have already seen this example before. इस example को हम लोग पहले भी देख चुके हैं. So if you still have any doubt regarding this example, you can always ask me. But this is one of the example of a grammar where we have production rules, and using these production rules, we will be able to create sentences. Okay? Do you have any doubt in this? तो इसमें कोई doubt है तो मुझसे पूछ सकते हैं. See, you will be able to create a lot of sentences, not just this 4. You will be able to create AB, double AB, triple AB, 4A and 4B, and then 5A and 5B and so on. You will be able to create a lot of sentences. So what I'm trying to do here is that I'm trying to identify the language generated by this grammar. So I'm trying to create all the possible strings and I'm trying to find out the pattern. So what will the pattern of the strings that it will be generated. According to the pattern, I can say this is the language that this grammar is satisfying. Okay, good. So I can wrap it up, I guess, if you have written it down. Yes, equal number of A's and equal number of B's. This is not the language. That is wrong. Priyanka, equal number of A's and equal number of B's is a different language. This is A raised to power n, B raised to power n. Okay, let me show you the difference between both of them. So what is the difference here? Okay, so let me show you. If I say the language is A raised to power n, B raised to power n such that n is greater than or equal to 1, and second language is W such that number of A in W is equal to number of B in W. So basically it is just like I'm writing in a shortcut form that number of A in a string will be equal to the number of B's. Now in this first language, the strings can be AB, we can have double A, double B, we can have triple A, triple B, and so on, correct? So here always A will come first and then B will come. But in this case, when we say that we have equal number of A and equal number of B, in this case we can have epsilon, because if we have epsilon, the number of A's are also 0 as well as number of B's are also 0. We can have AB and BA, because in this string number of A and number of B are equal, in this string number of A and number of B are also equal. In the same way we can have double A, double B, we can have AB, AB, we can have BA, BA, we can also have A, B, B, A, we can also have B, double A, B, and so on. So we will see there are a lot of strings which are present in this language, but these strings are not present in this language. So it is important and you have to take it carefully whenever you say that equal number of A and equal number of B. You should be very careful that what is the difference between A raised to power n, B raised to power n and equal number of A and equal number of B, because these are two different languages. ये दोनों same language नहीं है, these are two different languages. इतना clear है सबको? Any doubts so far? Good. So now I can take a grammar for this. For this I've already created one grammar. So the grammar will look something like this. S can derive A, S, B / AB. This is something that we have already seen. Now for this also we can have a grammar. The grammar will be something like this. S can derive A, S, B, or B, S, A, or AB, or BA. Something like this I can say, correct? So I don't know if it is correct or not, I have to check, right? So how can I check? I want to see can I generate this kind of string? क्या मैं इस तरह की string को generate कर पाऊँगा? Will I be able to create this string? So you will find out that yes, you will be able to create this string. Will I be able to create this string from here? क्या आप इस तरह की string को generate कर पाएंगे? So you have to check कि क्या इस string को आप generate कर सकते हैं, which is BAB, right? So then I can say, how will you generate? I can say S can derive BSA, correct? Further this S can be replaced by BA, so BA. So you will be able to create this string, but you will not be able to create this string. Why? Because here the first symbol and the last symbol is same. Now in this string also the first symbol and the last symbol is same. So even if you modify this grammar this way, अगर मैं इस grammar को इस तरीके से modify करता हूँ, still this grammar will not be able to generate all the strings which is present in this language. इस language में जितनी भी string present है, ये grammar उन सभी strings को generate नहीं कर पाएगी, right? So here we have to make sure, here we have to again change this grammar in some way that we will be able to create this string and we should be able to create this kind of strings. Okay, for sure we will be able to create this string from this, as well as we will be able to create this string, we will be able to create this string, but we will not be able to create these two strings from this given grammar. Okay, इतना clear है? So but again, let me not confuse you right now. I can create a grammar for this, but let me not confuse you right now. Let me just do one thing. I will I'll go step by step. Instead of confusing you with this difficult example, first of all I will go step by step. I'll take some simple and easy example first of all to create a grammar for a language, and then we will take difficult examples one by one. Okay, तो हम सब कुछ करेंगे लेकिन step by step करेंगे. So Pratibha AA/B will not be there, so that will not make it correct. So I'll come to that point step by step. So right now just don't get confused. Okay, so even if you add that AA/B, still this will not be a correct grammar. तो उस केस में भी ये correct नहीं होगा. Okay, so let us take step by step. The first language is W such that length of W is exactly 2, right? So over summation is equal to A comma B. Then the second language is W such that length of W is less than or equal to 2, over summation is equal to A comma B. And the third language is W such that length of W is greater than or equal to 2, over summation is equal to A comma B. So first of all let us create grammars for these three cases. सबसे पहले इन तीनों केसेस के लिए हम लोग ग्रामर क्रिएट करेंगे. So in the first case what we are trying to say is the length of the string will always be 2. सिर्फ 2 लेंथ के स्ट्रिंग पॉसिबल है. Now for this case I can explain you the grammar in multiple ways. मैं आपको कई अलग अलग तरीकों से ग्रामर बनाना सिखा सकता हूँ. So let me explain with 2 different ways first of all. So the first way is what you can do is you can write down all the strings which will be present in this language. So the strings that will be present in this language will be AA/AB, AA/ और एक comma AB, comma BA, comma BB. तो ये जो string है, this string can be present in this language. Now if I create a grammar, I can say S can derive AA/AB/BA/BB. So basically if the number of strings in the language is finite, अगर किसी language में finite number of strings है, then you do not have to worry about it, because in that case it will be very easy to create the grammar, because you can just put a slash and you can write all the strings. That's it. अगर आपके पास किसी language में number of strings finite है यानी कि fixed है, so giving a grammar for that language is very easy. So just like here I have given a grammar for this. Okay, now there is one more way I can explain this. How can I create one more grammar here? So if you understand, there is a regular expression for this language. इसके लिए एक regular expression हमने बनाया था. Just try and remember the regular expression. So the regular expression is A plus B dot A plus B. So this is a regular expression for this given language. Okay, now what we can do is we can take this regular expression and we can say, let us suppose this first part I'm going to represent it by capital A, and I can say the second part also I can represent it with capital A. Why? Because this part and this part both are looking exactly the same. So what I can say is S can derive capital A because these two are concatenated, so I can concatenate here, and then I can say A derive A/B. So this is the grammar. So basically this grammar and this grammar both are exactly the same. जो दोनों grammar हैं यहाँ पर both are exactly the same because they are going to generate the same string. दोनों grammar से आपके पास exactly एक ही जैसी strings generate होगी. Okay. So in simple words, अगर मैं simplicity से कह सकता हूँ, if in a simple word, how can you convert a regular expression to a grammar? How will you do it? Whenever you have a dot, just use a dot. Whenever you have a plus means union, just use a slash. That's it. इतना clear है सबको? Okay. So by the way, जितने students देख रहे हैं, please like the video. All the students who are watching the video, this live class, please like the video if you find it helpful. Okay. So if you take the next example here, for the next example I can create a regular expression like this, और उस regular expression से I can create a grammar. Okay, so here we have a regular expression. We have already seen this example, right? We have already seen it before. So the regular expression is something like this: epsilon plus A plus B dot epsilon plus A plus B. This is an example that we have already seen. इस example को हम लोग already देख चुके हैं कि इस language के लिए we can give this regular expression, because you understand if you open it you will get all the possible strings which are present in this language. तो इस language में जितनी भी possible string है you will get all of them using this. So what I can do here is I can use a capital A to represent this. So obviously I will also be using capital A to represent this. So for this language I can say we can have S can derive capital A dot capital A, where capital A can derive epsilon slash A slash B. That's it. So this is your ग्रामर फॉर दिस लैंग्वेज. इस लैंग्वेज के लिए हमारे पास ये ग्रामर हो जाएगी. इतना क्लियर है सबको? इज इट क्लियर विद ऑल ऑफ यू? ठीक है. इफ इट इज क्लियर लेट मी गिव यू सम एग्जांपल्स हियर. तो कुछ एग्जांपल्स मैं यहाँ पर ले सकता हूँ आपके लिए सो दैट इट बिकम्स इजियर फॉर यू टू अंडरस्टैंड. सो द ग्रामर इज लाइक दिस. एस कैन डिराइव ए एंड ए कैन डिराइव एप्सिलॉन स्लैश ए स्लैश बी. दिस इज योर ग्रामर एंड यू ट्राई टू अंडरस्टैंड व्हाट आर द स्ट्रिंग्स प्रेजेंट इन दिस लैंग्वेज. इस लैंग्वेज में क्या क्या स्ट्रिंग्स प्रेजेंट होंगी. द स्ट्रिंग्स विल बी एप्सिलॉन, सिंगल ए, सिंगल बी, डबल ए बी, बी ए, बी बी. So these are all the 7 strings that are present in this language. इस लैंग्वेज में हमारे पास 7 strings होंगी. कौन कौन सी? एप्सिलॉन, A, B, A, B, B and B B, because the length of each string is less than or equal to 2. यहाँ पर हर एक स्ट्रिंग की जो लेंथ है वो लेस देन और इक्वल टू 2 रहेगी. सो व्हाट आई वांट इज आई वांट टू जनरेट ऑल दीज पॉसिबल स्ट्रिंग्स यूजिंग दिस ग्रामर. ये जितने भी स्ट्रिंग्स यहाँ पर पॉसिबल है आई वांट टू जनरेट ऑल दीज पॉसिबल स्ट्रिंग्स यूजिंग दिस ग्रामर. सो हाउ विल यू जनरेट? सो द फर्स्ट स्ट्रिंग हियर इज एप्सिलॉन. तो सबसे पहले हम एप्सिलॉन को जनरेट करना चाहते हैं. हाउ विल जनरेट? सो यू कैन डू एस कैन डिराइव capital A. Further this A can be replaced by epsilon, so this is epsilon dot A. Further this A can also be replaced by epsilon, so this is again epsilon dot epsilon, which is equal to epsilon only. So using these steps we will be able to generate epsilon. Now how will you generate B? So I'm just telling about B. I'm not generating A because I think if I tell you B you will be able to generate A also. So how will you generate this B? You can say S can derive capital A. Further this A can be replaced by epsilon, so I get epsilon dot A. Further this A can be replaced by B, so it will be epsilon dot B. So the string will be B only. So this way you will be able to generate these B. In the same way you will be able to generate each of these 4. Let us assume I want to generate AB. So how will you generate AB? It is very easy. So you can say S can derive double A. Further this A can be replaced by this A, so it is A capital A. Further this A can be replaced by this B, so it is A B. So this way you will be able to generate these AB or BA and these strings. So basically using this grammar you will be able to generate all the possible strings present in this language. I hope this much part is clear. इसमें कोई doubt है till now? Do you have any doubt so far? Good. Now the language number 3 here. So language number 3 says that the length of the string should be greater than or equal to 2. Now again I can write all the possible strings here, or better ways I can write a regular expression for this. So what will be the regular expression for this? So for this I am going to create a string which is of length 2 and then I can concatenate mode length with it. So this is A plus B dot A plus B dot A plus B whole star. Now you can look at it here. It is very clear that we are also generating star here. Okay, so just try to understand what it means. It means that I'm going to have a string of length 2 and then I can concatenate all the possible strings with this language. So that means if I can represent this A plus B with capital A, I can represent this A plus B with capital B, and then I will be this is capital A, then I will be able to represent this with capital B. तो आप इसको कैपिटल बी से रिप्रेजेंट कर सकते हैं. देयरफॉर योर लैंग्वेज ग्रामर विल बी एस कैन ड्राइव कैपिटल ए एंड बी. आई होप इट इज विजिबल. आई थिंक आई हैव वेरी लेस स्पेस बट अगेन so this will be S can drive capital A and B. Further we know the definition of A. So capital A will be something like this, which is A slash B. Correct? Now my aim is to give the definition for B. Why it is difficult for B? Because B is using a star here. Star means it is a clean closure. So that means I want to generate all the possible strings using A plus B. इतना clear है? So I have to give a definition for B here. So before I give you the definition of B, let me explain you one more point and then I can come back to the same problem. I will give you a definition of B. Okay, so let me rub it up. Okay, so I told you whenever in a regular expression we have a star, if I convert it for finite automata, that means I have to put a loop, right? That means if you have a language which is A star, this is your language which is A star, so that means the strings which are present in this language, they are going to be epsilon, A, double A, triple A, and so on. So if you are going to create a finite automata for this, that means I'm going to have one state and I'm going to put this in a loop, correct? Now if I have to generate this one from grammar, so what I can do is I can say it is S can derive AS slash epsilon, that's it, right? So why I'm doing this, why I'm using this epsilon? I'm using this epsilon because even epsilon symbol is present in the language, right? So because epsilon symbol is present, that is why this epsilon should be there. And why I'm using this S, so this S is basically recursively creating all the possible strings in the language, right? So recursively means you will be able to create this string. How will you be able to create this string? You can say S can derive AS, and further this S can also be replaced by epsilon, so this is A dot epsilon, which is equal to A only. You will be able to create this string. How? You can say S can derive AS, further this S can also be replaced by AS, so AAS, and further this S can be replaced by epsilon, so it is double A. So this way you will be able to create this string. So basically whenever I have a loop, so in the same way I have to create this loop in this production using a recursive fashion. So this is a recursive definition, right? So here in this case we are having a recursion on the right side. So I'll tell you that concept, what is the recursion on the right side, I'll tell you that concept, left side recursion, right side recursion, we'll come back to that later on. So just understand that here I'm creating this loop using the help of recursion. So in the same way, if I want to generate, let me rub it more because I need more space here. So I believe I have to use a bigger whiteboard next time because this is kind of small for me. So in this case, if I have to generate language is A plus B whole star, if this is a language which is A plus B whole star. Now in this case also again I have to produce star. So how will you do? You can do, because it is every possible combination of A and B. So this is S can derive AS slash BS slash epsilon. So using this you can generate any possible string in this given language. Every possible string which is present can be generated using this. So the same concept you can use here. So for this, because the responsibility of B is to generate this, so I can say B can generate AB slash BB slash epsilon. So this is your grammar which can produce this above language. So इस grammar से आप इस language को produce कर सकते हैं, right? So you guys are correct. So it is AB slash BB slash epsilon. You guys are absolutely right. You guys are super smart. आप बहुत ही इंटेलिजेंट है, and you guys are super duper smart. Okay, so let me rub it up. आप लिख सकते हैं if you want. Otherwise, I will take more examples. See, why I'm taking these basic examples, even though everyone takes them, because this is very easy to explain using these examples, right? तो इन एग्जाम्पल से समझाना बहुत आसान है. And secondly, those students who are asking me, sir, what is a book you can refer? I told you that the standard book for this subject is Peter Linz. Peter Linz जो है वो एक standard book है. But again, sometimes it becomes difficult to understand from that book. So you might want to ask me about local author books. Some of you ask, sir, what is a local author book you can refer? So one of the book is KLP Mishra, that is your local author book, and second book you can refer is Puntam Baker. So this is a book which is A. Puntam Baker. So I basically use these books because a lot of the examples that I take that are directly from this book. So you can use it. It will be very good, okay? Because the way I teach and the examples I take, everything is from this book only, okay? I found that this book is very easy to understand. So obviously they are not paying me for this, but again, I found that this book is very easy to understand. So that is why I am referring you. Otherwise, you want to have it, you can take it, okay? Now, let me take another language. See, most of the people, they follow this book. I mean, in South Indian universities they follow this book, and I found it quite interesting. Now the next language is W such that length of W mod 2 is congruent to 0 mod 2. So I'm just writing in shortcut because I don't want to waste a lot of time. Next language is W such that length of W mod 2 is congruent to 1 mod 2. Next language is W such that length of W mod 3 is congruent to 1 mod 3. Right, so you can also say 0 mod 3, or you can say 2 mod 3. So let us take 2 mod 3 this way. Okay, and let me take one more example. Language is W such that number of A's in the string W mod 2 is congruent to 0 mod 2. So by the way, again I can say this one will be difficult. This one will be difficult as of now, so I might want to skip it. So I'll see after explaining how comfortable I feel that you will be able to understand this. I can make grammars for this very easily, but the problem is I don't want to make unnecessary complicated statements. So we'll go step by step. So I want all of you to understand everything, or because अगर आपको समझ आएगा, that will be very good. Okay. So this is the first language, second language, and the third language. So in the first language, it is saying that we will be able to create even length strings. So in this case, for the language L1, you can create a regular expression. Language L1 के लिए आप एक regular expression बना सकते हैं. So what will be that regular expression? So regular expression will be something like this, that we have for this we can create W, length of W mod 2. So it is A plus B dot A plus B whole star. So again, see, most of the examples I'm taking as summation is A comma B. So here we have two length strings, and I'm generating the permutations of these two length strings. Okay, so we will be able to create all the even length strings from this. Okay, so what I can do is I can take capital A for this. I can represent it with capital A. I will also be representing the same with capital A, because this and this, these are exactly the same. And because I have a star, so I have to generate it in a loop, right? So what I can do is I can say S can derive capital A, capital S. So why I'm using this S? Again, because recursively it will be generating the same thing. And then I can also generate epsilon. That's it. And where capital A can generate small a slash small b. So this will be able to generate all the possible strings of this language. So it will always generate even length strings. So do you want me to explain this? I think you do not want me to explain this because this is very easy. But still, if you want explanation about it, that how can you generate strings from it, please ask me. But I feel this is very easy. Okay. अगर आपको लगता है that you want more explanations about this, please let me know. So if you take the second example here, the language L2. So the language L2, the regular expression will be something like this. We have A plus B. I'm going to have a string of length 1, and then I can concatenate even length strings for this, which is A plus B dot A plus B whole star. This is something we have already seen. ये हम already देख चुके हैं. Okay. So in this case, this is if I say this is capital A. Okay, and then I want to generate this entire with capital B. Okay, so you'll understand why I'm saying it this way, because it will make it much easier to implement. I can say S can derive capital A and B, where capital A can generate small a and small b. So this small a and small b can be generated by capital A, and this entire string I want to generate with capital B, and then I can say capital B will be able to generate capital A, capital B, capital B slash epsilon, and that's it. So this is your grammar, and using this grammar you will be able to generate all the possible strings of this language. You can check it out. Okay, आप generate करने की कोशिश कर सकते हैं, right? So Aditya, the language that you are giving, this is not correct. So I mean the grammar that you are giving, that is not correct. So maybe you want to check here. Okay, so let me just show you what are the strings that will be generated from this grammar. So the grammar is like this. S can derive AB, where B can derive capital A, B slash epsilon, and A can derive small a slash small b. This is your current grammar. And this grammar is to generate all the odd length strings. So let me see what is the minimum length string that you can generate. So because the minimum odd length is 1, so can you generate a string of length 1 from this? Yes, obviously you can. How? S can derive AB. I can replace this A by small a or small b. So I can replace this by small a, then we have a b, and then I can replace this b by, epsilon. So this is a dot epsilon, which is equal to a. So that means you will be able to generate a string of length 1. Will you be able to generate a string of length 3? Obviously you can. How? S can derive AB. Further this a can be replaced by small a, and then we have capital B, and further this b can be replaced by capital A and B. So further this a can be replaced by small a and small b, right? And further this a can be replaced by small a or small b, and further this b can be replaced by epsilon, right? So this is the string that we can generate. So we will be able to generate string of length 3. Now you will notice one thing while I was driving this. तो आपने एक चीज़ बहुत important notice की होगी, because that is very very important. So what is that thing? You must have noticed whenever I give these sentential form in one step, I resolve only one symbol. I do not resolve more than one symbol, even though it is very very easy to understand that this a can be replaced by small a, this b can be replaced by small epsilon, even though it is very easy to understand. But again, it is a rule, you can say, whenever you write a sentential form, so in one step you only replace one symbol. You do not replace more than one symbol. इतना clear है? So you do not replace more than one symbol in one step. And secondly, we have two kinds of derivations. One is your leftmost derivation, and second is your rightmost derivation, LMD and RMD. LMD means if in every step you are replacing the leftmost symbol, right? Leftmost symbol means leftmost variable. Whenever I am saying a symbol, it means it is a variable. So if I say we have leftmost derivation, that means in every step whatever the leftmost symbol is, so here the leftmost symbol is a, so whatever the leftmost symbol is, I'm going to replace the leftmost symbol. And if I say that we have RMD, so in case of rightmost derivation, we always replace the rightmost symbol. So the rightmost symbol will be B, right? So first we will resolve B, then we will resolve this A, then we will resolve the next symbol, and so on. So in every step, if you only resolve the rightmost symbol, that becomes RMD. In every step, if you resolve the leftmost symbol, that is it become LMD. So there's a difference between leftmost derivation and rightmost derivation. And why does it play an important part? देखो, why is it so important to understand the difference between LMD and RMD? Even though we can say, sir, in the end same string will be produced. सभी ऐसा बोलेंगे कि सर लास्ट में तो स्ट्रिंग तो सेम ही प्रोड्यूस हो गई, राइट? तो क्या फर्क पड़ता है कि हम LMD करें या फिर RMD करें? What does it create a difference, right? It definitely create a difference when you study the compiler design subject, because in compiler design you will understand that when a program is generated from a grammar, then the program can be generated from a leftmost derivation. It can also be generated from a rightmost derivation. And if it is generated from a leftmost derivation, the result of the expression will be different. If it is generated from the rightmost derivation, the result of the expression will be different. Okay, so let me give you one important factor here. What is the importance of these grammars? इनकी सबसे ज़्यादा इंपॉर्टेंस क्यों है? वाई आर वी इवन स्टडिंग दीज ग्रामर्स? इनकी सबसे ज़्यादा इंपॉर्टेंस क्यों है? लेट मी मेक यू अंडरस्टैंड दैट. फर्स्ट ऑफ ऑल लेट मी मेक इट वेरी वेरी क्लियर. देखो, वेन एवर यू से वी हैव लैंग्वेज, लाइक वी हैव अ सी लैंग्वेज, राइट? सो इसमें जो वर्ड है लैंग्वेज, दिस वर्ड इज वेरी इंपॉर्टेंट. Why this word is very important? Because C language or C++ languages, these languages are context free languages. These are your context free language. Okay, then you have like C, C++, Java, most of the programming languages, these are context free languages. These are not context sensitive languages. जितने भी आपके programming languages हैं वो सभी context free languages हैं, वो context sensitive languages नहीं है. Correct? Now why are these languages? इनको languages क्यों बोलते हैं? देखो, given a programming language, there are infinite number of different programs are possible. आप किसी प्रोग्रामिंग लैंग्वेज से अलग अलग इन्फिनिटी अलग अलग प्रोग्राम्स आप बना सकते हैं. अकॉर्डिंग टू योर ह्यूमन लॉजिक यू कैन राइट thousands of lines of code, you can like lakhs of lines of code. There are a lot of lines of code that you can write, but how will the compiler know whether that program is correct? How will it know, right? So you know that we have a compile time error, we have a runtime error, we have a lot of different types of error, right? So if you have created some program, how can the compiler understand that this program is syntactically correct? क्या ये program syntactically correct है या नहीं है? So what will the compiler do? So compiler will be having a grammar just like this, just like we have a grammar like this. In the same way compiler will be having a grammar. So that grammar will be defining a lot of things. So for example, what is the rules for creating a variable name? To create a variable name we are having a grammar. So if I give a name of a variable, so they will check whether this name is valid or not. How will they check? They will try to generate this given string from the given grammar that they have. And if they can generate this string from that grammar, they can say yes, this is a valid name. In the same way your entire C program is considered as a one string. आपका जो भी प्रोग्राम है उसको एक स्ट्रिंग की फॉर्म में कंसिडर किया जाता है. And they say that the grammar which is given for the C language, if this grammar can generate this entire program, that means this program is valid. If this grammar cannot generate that entire program, then we say the program is not valid. Correct? And now I also told you how the expressions are evaluated. For example, I told you if I say we have A plus B plus C, or we can also have A multiplied by B divided by C. So how will this expression be evaluated? So if this expression is evaluated left to right, then the result will be different. If this expression will be evaluated right to left, then the result will be different, right? So if you evaluate it this way, right, left to right, result will be different. If you evaluate this one first and then that expression, the result will be different. So whenever the compiler tries to produce that given program, it will try to do either a leftmost derivation or it will try to do either a rightmost derivation, and according to the derivation the meaning of the program might change. So it is important, even though this thing is very trivial. आप कह सकते हैं कि सर ये तो बहुत ही बच्चों वाली चीज़ है, why you were telling it, but this plays a very very important role when you are studying compiler design. अगर आप compiler design study कर रहे हैं उसमें this plays a very very important role. So this is something that you should know. Okay, clear है सबको? C and C++ are context free languages. They are not context sensitive. Okay. Good. So I'm not discussing about compiler design as of now. I think some of you have already studied compiler design. Some of you are already discussing about this LL1 and so on, right? So fine, so we'll discuss that. Pratibha, don't worry, I'll just have a look at it and I'll update you regarding the same. ठीक है, मैं उसको check करके I'll update you. So let us move forward here. So I'll take more examples here. So if you take this example, which is the language L3, for language L3 I think you can give me a grammar for this. आप सभी मुझे इसकी grammar दे सकते हैं. So can you write the grammar in the chat window? Just write a grammar for the language L3. I'm going to just check all your messages and then I'll reply. L3 के लिए please give me a grammar. So basically, Pratibha, I checked this up. So whatever you said, I checked it up. So what they are saying is that C grammar is a context free grammar. जो C language है उसकी जो grammar है वो context free grammar है, but the language is having a context sensitive properties. So just like we have a context sensitive language and we have a context free grammar, right? These are two different things. Context sensitive language is a different thing and context free grammar is a different thing. So whenever you have a context free grammar, it will be able to generate your context free languages. But again, C language, the grammar of the C language is context free, but the language that is generated by C language is context sensitive. This is what they are trying to say. But again, that is something like a theory, right? So it is not written in the textbooks. That is more like a theory. Okay. So they say that language, C language and C++, they are context sensitive languages, but the grammar used is a context free grammar. Clear sabko? Is it clear? So this was a question in GATE 2012 also. They asked the C language is a context free language, it is a context sensitive language, it is a regular language, or it is a parsibly something, right? So they say the answer, the official answer is the C language is basically your context sensitive language, but the grammar is context free grammar. Okay? I hope that I answered your query. Now let me take this example here. So in this case, in the language L3, we have length of W mod 3 is congruent to 2 mod 3. So length of W mod 3 means it is, first of all, we are going to generate a string of length 2. And then now because it is 2 mod 3, right? So we have to generate multiples of 3. So it is a plus b dot a plus b dot a plus b whole star, right? So this will be your regular expression for this. So what I can do is I can represent it by capital A. This will also be by capital B, and this entire with capital B. So I can say S can derive capital A, and capital B. Further, this B can generate, this is A, this is A, this is A. So A, B slash epsilon, and further this A can generate small a slash small b. This is your grammar for this language. So this language, this is how you can create a grammar. So I hope that you guys have created this one. So most of you have created the right one. तो आपने सही बनाया है. So Pratibha, your answer is also correct. So your answer is not wrong, it is correct. Okay. So even if you create BAA, so even if here in this specific case, even if you write BAA and AAB, that both of them will be correct. तो उसमें आपको कोई problem नहीं होना चाहिए. Okay. So ठीक है. Now let me, I think because you guys have asked me what is the difference between a context free language and context free grammar. So let me just give you a few more examples here. Okay, before that, just solve this language. I mean, give a grammar for the fourth language here. So in the fourth language, we can give a regular expression for this, and the regular expression will look something like this, that we can have a plus b whole star, or I should say it, we can have b star a, b star a, b star whole star. So this will be your, this will be entire be a regular expression for this given language. Because here they are saying the number of a should always be even. So a will always be in a multiple of 2. And we can also generate any number of b's. We can also have any number of b's here. So but a will always be even, correct? So what I can do is, to represent this b star, I can use a variable, let us suppose, which is capital B, and for this entire thing I'm using a variable which is capital A. So I can say S can derive capital A slash capital B, where the job of this variable B is to generate B star. So I can say this variable B will be able to generate BB slash epsilon. So variable B जो है वो BB slash epsilon को generate कर पाएगा. Now the job of this variable A is to generate this everything in a loop which is star. So it will be able to generate something like this, which is B. So B is capital B, then we have A, right? So for this A, I'm just using small a variable, then again we have B, then we have A, then again we have B, and because we want to generate this entire thing in a loop, so I can say it is capital A slash epsilon. So using this grammar, you will be able to generate all the possible strings where the number of A's are always even. तो यहाँ पर जितने भी A होंगे हमेशा, they will always be even. Clear है सबको? So I hope this answered your question. So let me give you this type of these grammars. देखो यहाँ पर you can take this example here and you will learn a lot of things about it. Okay, first write it down in your notebook and please write done in the chat window. इसको notebook पे लिखकर please write done. Good, because you have written. So basically the types of grammar, there are different ways how you can basically tell what are the types of grammar. The first way is based on the type of production rule. The type of production rule. Okay. And second, on the basis of the derivation tree. Right, so basically these are three ways how you can categorize a type of grammar. The first category is according to the type of production rule. The second category is according to the number of derivation tree. According to the number of derivation tree. Okay. And the third category is on the basis of number of strings that the grammar can generate. Okay. So there are three different types जिस तरीके से आप categorize कर सकते हैं. According to these types you can categorize a grammar. तो तीन types से आप grammar को categorize कर सकते हैं. The first one is the type of production rule. So according to the type of production rule, you can say a grammar is a type 0 grammar, it is a type 1 grammar, or it is a type 2 grammar, or it is a type 3 grammar. So we have type 0 grammars, type 1 grammar, type 2 grammar, and type 3 grammar. So these type 3 grammars are also called as regular grammar. These type 2 grammars are also called as context free grammar. These type 1 grammar are also called as context sensitive grammar. And this type 0 grammar is also called as your unrestricted grammar. Are you guys able to see me? क्या आपके end पर is it buffering or is it going smooth? Okay, is it buffering or smooth, the live streaming? No, fine. Okay, good. So again I was telling you the types of grammar according to the production rules. तो according to the production rules मैं आपको types of grammar बता रहा था यहाँ पर. ठीक है. So we have type 3 which is also called as a regular grammar. तो जो type 3 है यहाँ पर, तो type 3 को हम लोग यहाँ पर regular grammar भी बोलते हैं. And what is this regular grammar? That means what is this type 3 grammar? क्या में से कोई बता सकता है what is the type 3 grammar? So if the grammar is either left recursive or it is right recursive but not both, then we say it is a regular grammar, or you can say type 3 grammar. Okay. So if the grammar is either left recursive, that means if the productions are the form, if productions are of the form alpha derives a beta or alpha derives beta a, but not both, where alpha comma beta, alpha belongs to the set of variable. Okay, so we have exactly one variable in alpha, and this beta belongs to variable or epsilon. Then we say it is a type 3 grammar. ठीक है, इतना क्लियर है आप सभी को? Yes, so I mean to say, देखो, what do I mean to say by this is, so let me first explain you with the help of example कि मैं क्या कहना चाहता हूँ, then you will be able to figure out what I am trying to say. ठीक है? So let me just explain this, what I want to say, then you will be able to understand. जैसे कि for example, if we have a grammar like this, which is s can derive as slash a. ठीक है? So this grammar here, it is a regular grammar. Why? Because here s is a variable. In place of alpha I've used s, which is a variable. In place of beta again I've used s, which is again a variable, and this is basically right recursive, right? So right recursive, here we say if the grammar is either left linear or the grammar is either right linear, or the grammar is either right linear, then we say it is a टाइप 3 ग्रामर. या तो ग्रामर आपकी लेफ्ट लीनियर होना चाहिए या फिर ग्रामर जो है आपके राइट लीनियर होना चाहिए, देन वी कैन से द ग्रामर इज अ टाइप 3 ग्रामर. ओके, सो लेट मी रब इट अप एंड आई शो यू व्हाट इज द डिफरेंस बिटवीन लेफ्ट लीनियर एज वेल एज अ राइट लीनियर. So for example, if we have a production which is s can derive a capital A, where a can derive small a. So this is your grammar and it is a regular grammar, it is a type 3 grammar. Why? देखो, if you look at this production, so if you try and generate the string from this, it can generate s can derive a and further a, and further this a can also be replaced by a. तो जो tree है, this tree is skewing on the right direction, it is growing on the right direction only, so that is why it is right linear. But again, if we have productions like this a slash small a, so now you can see you will be able to generate all the strings and the production tree will only grow in the right direction, right? So if you generate one more string here, so you can say s can derive a capital A, further this a can be replaced by a capital A, further this a can also be replaced by small a, so the string that will be generated from here is a. So here the string that is generated is double A, here it is triple A. So you can see this tree is only growing in the right direction, therefore we can say it is a right linear grammar. यानी कि आप right side की तरफ lean हो रहे हैं, you are growing only the right side, so that is why we can say it is a right linear grammar. Now we also have a left linear grammar, that means the tree is only growing at the left side. So if you have a productions which are of the form, अगर आपकी productions कुछ इस तरीके से है, which is s can derive a slash a, further this a can derive a slash a. So if you try and generate all the possible strings from this, the tree will only grow in the left direction. Or even if you take a grammar like this, which is s can derive sa slash small a, so this is your grammar. So if you try and generate every possible string, so the strings can be s can derive either single a or s can derive s a, further this s can be replaced by this a, so the string that will be generated is double a, or s can derive s a, further this s can replace s a, further this s can be replaced by a, so the string that will be generated is triple a. So if you look at these three examples here, the tree is only growing in the left direction, here the tree is only growing in the right direction, so this grammar is a left linear grammar and this grammar is a right linear grammar. So here what I'm trying to say is, if the productions are of this form, which is a right linear production, or if the productions are of this form, this is a left linear production, then we say that the grammar is a regular grammar. तो उस केस में जो grammar है वो हमारी regular grammar है. But if I say that we have a grammar like this, which is s can derive a, where a can derive, let us suppose a b slash b. नाउ दिस ग्रामर इज नॉट अ रेगुलर ग्रामर. ये जो ग्रामर है ये रेगुलर ग्रामर नहीं है. It is not a regular grammar. Why this is not a regular grammar? Because the first production that we are seeing here, the first production, it is a right, in the right direction we have A, but in the second production on the left direction we have A. So according to the first production we should say that grammar is a right linear. According to the second production we should say the grammar is a left linear. But again, because of these productions, these kind of productions where we have mixed something, so we can say this grammar is not regular. Or if I have a grammar like this, I can make it much easier to understand. I can say S can derive A S, or it can generate small a. So this first production here is recursive on the right direction. It is right recursive production. And the second production is recursive on the left direction. It is left recursive production. Then we can say that the grammar is not regular. अब ये जो grammar है, this grammar is not regular at all. ये जो grammar है ये regular नहीं है. Understood? So this grammar is a regular grammar. This grammar is also a regular grammar. This grammar is not a regular grammar because these productions are a mixture of left linear as well as they are a mixture of right linear. Clear हुआ सबको? Good. If it is clear, you guys are super smart. अगर आपको clear है, because मुझे तो पहली बार में समझ नहीं आया था. When I was studying it for the first time, I could not figure it out easily. So it took me a lot of time to understand these things. So you guys are super intelligent, I guess. I wish I could have a mind like you. I was so tougher in studies. So we have a type 2 grammar here. So type 2 grammar is a context free grammar. So context free grammar says if you have production which is the form alpha derives beta, where alpha belongs to the set of variables and beta belongs to the set of variables union terminal star, then we say the grammar is a type 2 grammar. Again I am repeating, the type 2 grammar says if we have all the productions are of the form which is alpha derives beta, where alpha is set of variables and beta belongs to the set of variable union terminal star. It is very important. Here I am using a star, here I am not using a plus, here I am not using a star. That means the length of alpha can be exactly 1. We can have only one variable on the left side. हमारे पास लेफ्ट साइड पर सिर्फ एक ही वेरिएबल हो सकता है. We can only one variable on the left side. But on the right side this b can be any combination of variable and terminal. तो जो b है वो वेरिएबल और टर्मिनल का कोई भी कॉम्बिनेशन हो सकता है. For example, if I say we have production like S can derive AA slash AB slash AABA slash epsilon. A can derive epsilon slash AAAA slash AA slash AB, and B can derive small a slash epsilon slash AB slash BA. So you can clearly see on the left side we have exactly one वेरिएबल. लेफ्ट साइड पर आपके पास सिर्फ एक ही वेरिएबल है. वी हैव एग्जैक्टली वन वेरिएबल. बट ऑन द राइट साइड वी कैन हैव एनी कॉम्बिनेशन ऑफ वेरिएबल्स एंड टर्मिनल्स. सो वेरिएबल्स एंड टर्मिनल का कोई भी कॉम्बिनेशन यहाँ पर हो सकता है. सो ऑन द राइट साइड वी कैन इवन हैव एप्सिलॉन, वी कैन हैव एनी कॉम्बिनेशन ऑफ वेरिएबल एंड टर्मिनल्स. सो वी कैन इवन हैव अ सिंगल terminal here, or we can also have a single variable here. Okay, so this is how we can say the grammar is a context free grammar. I'll give you one more example here. If I say that we have S derives double AB, where A derives small a and B derives small b. Now if you look at this grammar also, if you look at this grammar, now this grammar is also a context free grammar. Why? Because in the left side we have exactly one variable. Left side पर आपके पास exactly सिर्फ एक ही variable है. But on the right side we can have any combination of variable and terminal. We can have more than one variables. We can have any combination of variable and terminals and so on. Then we say the grammar is a context free grammar. Is it clear? Is it clear with all of you? Any doubts in context free? Good. Now the third one here is context sensitive. अब जो सबसे जो हमारा third one है वो है आपके पास context sensitive. तो context sensitive का मतलब क्या है? What do you mean by context sensitive? Context sensitive means if we have the productions of the form alpha derives beta, where alpha belongs to variable union terminal plus and beta belongs to variable union terminal star, and at the same time length of alpha is less than or equal to length of beta. Length of alpha is less than or equal to the length of beta. Okay, so I hope this is visible. I have a very less space, so I have to write it this way, but let me explain this again. What I'm trying to say is, on the left side we can even have a terminal. So here you can see on the left side we are only having a variable. When you have a context free grammar, तो context free grammar में left side पर आपके पास सिर्फ एक variable ही आ रहा है, but in this context sensitive grammar on the left side you can also have variable and terminal, but the length of the left hand side should be less than or equal to the length of the right hand side. जैसे कि if I say we have a grammar like this, S can derive AA BB slash AB slash epsilon, where AA can derive BAB, and we have capital A can derive BB, where BA can derive epsilon slash B slash A slash epsilon. So you can see here on the left hand side. So by the way, grab it the sub, let me make it more clear. BB and let it make BB and so on. So why I'm taking it this way, why I just changed, why I rubbed some value, because they are saying the length of the left hand side should be less than or equal to the length of the right hand side. तो जो left hand side की जो length है वो right hand side की length से less than or equal to होना चाहिए. So here you can see this is, we have the length is 2 and here the length is 3. Okay, so in the left hand side also we can have a combination of variable and terminal. Here also we can have a combination of variable and terminal. We can also have a variable, but the length of the left hand side should be less than or equal to the length of the right hand side. But at the same time this can also have epsilon. On the right hand side you can also have epsilon. So if you look at this definition more clearly, अगर आप इसको definition को थोड़ा ध्यान से देखेंगे, you will see on the left hand side we have a plus, on the right hand side we have a star. That means on the left hand side we cannot have an epsilon. Left hand side पर आपके पास epsilon नहीं हो सकता, but on the right hand side you can have epsilon. Right hand side पर आपके पास epsilon हो सकता है, but on the left hand side you cannot have an epsilon. Okay, so this is an example of a grammar which is not context free, but it is a context sensitive grammar. ये grammar जो है ये context free नहीं है, लेकिन ये context sensitive grammar है. ठीक है, I hope that this much is clear. अगर ये क्लियर है then I can rub it up and I'll write more because I have very less space. तो मुझे रब करना इज़ मेरी मजबूरी, तो मेरी मजबूरी को मेरी कमज़ोरी मत समझना. I think you guys are sleeping. आप में से कितने लोग अभी सुन रहे हैं? How many of you are actually listening to the lecture? Replies नहीं आ रहे. I'm not getting replies in the chat window so frequently. Replies आते हैं, it becomes very good for me. Do some replies on the chat window, my dear friends. सिर्फ यहाँ नहीं, वीडियो को भी लाइक करो. चलो, anyways, so let's continue then. So then we have a type 0 grammar. The difference between a type 1 and type 2 type 0 is only this one. So in case of type 1 grammar, you have length of left hand side should be less than or equal to the length of right hand side, but in case of type 0 grammar this difference is also not there. So you can see that this is, if I give the definition, it is alpha derives beta, where alpha can be any combination of variable union terminal plus, beta can be any combination of variable union terminal star, but the only difference between this one and this one is this. सिर्फ यही एक difference है between a type 1 and type 0. So in case of type 1, the left hand side is always less than or equal to the length of right hand side, but this condition is not valid for type 0 grammar. तो जो type 0 है वहाँ पर ये condition valid नहीं है. Clear है सबको? Is it clear? So now you can clearly see that these grammars are basically more restrictive. If you have type 0 grammar, then we have some minimum restrictions, very less restrictions in type 0. Then we put some extra restrictions in a type 1 grammar. Then we put some extra restrictions in a type 2 grammar. Then again we put some extra restrictions in a type 3 grammar. So that means I can say every type 3 grammar is also a type 2 grammar, but every type 2 grammar is not type 3. And every type 1 grammar is also, every type 2 grammar is also a type 1 grammar, but every type 1 grammar is not type 2. Now in the same way I can say every type 0 grammar is not type 1, but every type 1 is also type 0. So here this is the minimum number of restrictions in the production. Here we put some restrictions, he put more restrictions, here we put more restrictions. So in this case we have alpha derives beta, where alpha can be any combination of variable and terminal, and beta can be any combination of variable and terminal. Alpha cannot be epsilon. Again here alpha derives beta, but the difference is the length of alpha is less than or equal to the length of beta. And then here in case of type 2, the restriction is on the left hand side we have exactly one variable, but on the right hand side we can have any combination. So here we are putting restrictions exactly on the left hand side, but right hand side we can have anything. And in type 3 you can see it is the most restrictive one, because type 3 is saying either the grammar should be left linear or the grammar should be right linear, but not both. जो ग्रामर है या तो लेफ्ट लीनियर होनी चाहिए या फिर जो ग्रामर है वो राइट लीनियर होनी चाहिए, बट दोनों नहीं हो सकती. ओके, इतना क्लियर है सबको? Now from this you can say that the languages generated by a type 3 grammar will be regular languages. The languages that is generated by type 2 grammar will be context free languages. The languages generated by type 1 grammar will be context sensitive languages. The languages generated by type 0 grammar will be recursively enumerable languages. So we will be discussing about all those languages one by one. So वो सब चीजें हमारे पास और आएगा. Okay. So let me wrap it up. I guess you have written it down. So this was the first category of the first category, how you categorize the grammars. Grammars को आप कैसे categorize कर सकते हैं, ये सबसे पहली category थी, on the basis of the productions. So what kind of production the grammar is having, I can categorize the grammars. Okay. Then we have another category of grammar, which is number of derivation trees possible for a given string. So here you can say either the grammar can be an ambiguous grammar or the grammar can be unambiguous grammar. Ambiguous and unambiguous. So what do you mean by ambiguous? Ambiguous is something that creates confusion. Correct? So let me explain this first. So what do you mean by ambiguous? देखो, when you have a certain language, I mean certain grammar, now from that grammar if you want to create a string, for the same string if you have two different derivation trees possible, then we say the grammar is ambiguous. Otherwise the grammar is unambiguous. Okay, let me explain you. Let us assume that we have a grammar which want to generate an expression. So we can say grammar is something like this: E can derive E plus E slash E star E slash number. So number I am representing by ID. So this is a grammar that will be generating an expression. जैसे कि आपके पास कोई expression है, you have an expression like we have A plus B multiplied by C. So I can say this A is represented by ID, this B is represented by ID, and this C is represented by ID. So that means we have ID plus ID multiplied by ID. So this is a string. Now to generate a string like this, is there more than one different derivation tree possible? So यहाँ पर by the way, what are the terminals? The terminal is plus multiplication in ID, and what are the variables? Variable is only A. Okay, so if I take any string whatsoever, so what are the strings this grammar can generate? I can take any string whatsoever. If for even a single string you can generate more than one derivation tree, I can say the grammar is ambiguous. Okay, so for example, if I want to generate this string, so how can I generate? You can say E can derive E plus E. Further this E can derive E star E. Further this E can derive ID, this can derive ID, this can derive ID. In this way you can say the string will be ID plus ID multiplied by ID. So this is one way of generating this string. But still we have one more way of generating the same string. How can you do? You can say E can derive E star E. So this is, you can see E can derive E star E. Further, this E can be replaced by E plus E. Further, this E can be replaced by ID. This can be replaced by ID. This can be replaced by ID. So if you look at the entire string generated by this, the string will be ID plus ID multiplied by ID. So you can see, to generate the same string, एक ही स्ट्रिंग को जनरेट करने के लिए there are two different derivation trees are possible, two or more than two different derivation trees are possible. Then we say the grammar is ambiguous. Ambiguous मतलब something which is confusing, जिससे confusion create हो. If you get a situation of confusion, then we can say it is ambiguous. Okay, so ambiguous, you can clearly see what ambiguity means. And when I say unambiguous, unambiguous means you will not be able to get different trees to generate same string. Let us suppose the grammar is S can derive AS slash epsilon. This is your grammar. Now you can take any possible string that this grammar can generate, any possible string whatsoever. Maybe the string is A. So you can take any possible string. You will never be able to find two different parse tree to generate the same string. So because you cannot create two different parse tree to generate the same string, so we can say this grammar is unambiguous. तो इस केस में जो grammar है ये आपकी unambiguous है. इतना क्लियर है सभी को? Any doubt so far? Clear so far? Doubts? Is it buffering in between? I think internet is not working. So is it buffering? I think it's not buffering, right? It's going fine right now. Good. It was actually having two different internet connections, so it was buffering on my connection, so that is why I asked. Okay, anyways, let's move forward then. So you understood what is ambiguous, what is unambiguous, and then we have the third category, how you can categorize a grammar. The third category is according to the recursiveness, whether a grammar is recursive or not recursive. You can have a grammar which is a left recursive grammar, you can have a grammar which is a right recursive grammar, and this way. Okay, so we can say a grammar can be recursive grammar, or the grammar can be non-recursive grammar. So if it is a recursive grammar, further you have a left recursive grammar, or you also have a right recursive grammar. जो ग्रामर है वो रिकर्सिव है या फिर नहीं है. जैसे कि let me explain you. If I have the grammar like S can derive double A B, where A can derive small a slash small b and B can derive small b slash small a. So this grammar is not recursive because recursion नहीं हो रहा है यहाँ पर. We are not having any kind of recursion whatsoever. Correct? It is a non-recursive grammar. But if I say we have a grammar like this, S can derive AB, where A can derive AA slash B, where B can derive BB slash A. So this is your grammar. Now if you look at this grammar, in the first production we are not having any recursion. यहाँ पर कोई recursion नहीं है. But in the second production we are having a recursion. So you can see this production here. So we are having a recursion on the right hand side. So this production is A can derive A, capital A. So this left hand symbol and this right hand symbol, that is on the right hand side, this symbol, these symbols are matching. Therefore I can say it is a right recursive production. In the same way, in this case also, this is a right recursive production. So I can say this is a right recursive grammar. So जो grammar है यहाँ पर right side में recursion हो रही है, so it is a right recursive grammar. I can also say that we have a grammar like this. S can derive E plus T slash T. T can derive T star F slash F. F can derive ID. So this is a grammar. So in this grammar we have variables. Variables are S, E, T and F. We have terminals which are plus, star and ID. Now in this given grammar, if you look at each of these productions, right, so this is first E, so let us remove S. So in the first production we have recursion on the left hand side. In the second production we have recursion on the left hand side, right? So because we are always having a recursion on the left hand side of these productions, so this is a left recursive grammar. So this one is representing a left recursive grammar and this one is representing a right recursive grammar. So according to the recursion also you can categorize the grammars. Itna clear hai sabko? Any doubt so far? I don't feel so that you are having any doubt, but ho to you can ask me, okay? So basically I can say there are three ways how you can categorize a grammar. The first way is according to the type of production. So we have a type 3 grammar, we have a type 2 grammar, we have a type 0 grammar and we have a type 1 grammar, okay? Now the second way is according to the ambiguity. So we can say the grammar is ambiguous or unambiguous. Mostly we discuss about this ambiguity in the case of context-free grammars only. Why? Because your compilers uses a context-free grammar. जो आपके compiler है C compiler or C++ compiler, they use a context-free grammar. So because they use a context-free grammar, so they want the certain compilers are there which cannot accept ambiguous grammars. So they do not take ambiguous grammar. They only take grammars which are unambiguous. And then we have third one, which is your according to the number of strings. So you can have a number of strings which are the grammar can be recursive grammar, the grammar can be non-recursive grammar. If the grammar is recursive, further we can have a left recursion in the grammar, we can also have a right recursion in the grammar. So according to these three ways you can categorize the grammar. तो इन सभी तरीके से आप grammars को categorize कर सकते हैं, okay? So as you are saying, Pratibha, so what you are saying is you can convert a production from left recursive to the right recursive. आप किसी production को left recursive से right recursive में convert कर सकते हो. Basically you can have mixed productions also, you can have mixed recursion also. But why this left recursive and right recursive is important? Because generally some of your compilers, so when we use compiler design, we are using the grammars which is left recursive, or sometimes you might use a grammar which is right recursive. Now some of your compilers might get into an infinite loop if you have a right recursion, correct? तो कुछ compilers ऐसे हैं which might go to an infinite loop. So according to the recursion, so right now I'm not I've not revised it, but again I think you can see that according to the program, when you create a program, when you create a function, so if you have a recursion in the beginning of the function, then there's a high possibility that this function can go to infinite loop. Accordingly, you can also have a function, you can have a termination condition in the beginning and then you can have a recursion in the end. So this recursion, because the recursion is in the beginning, so this is representing left recursion, right? So that means, so let me correct my sentence again. So that means we are saying there are some compilers, if in those compilers you give a production and the production is a left recursive production, then this kind of case might occur. It means the compiler can go to an infinite loop when it is parsing a program. जो किसी प्रोग्राम को पार्स करते हुए कंपाइलर जो है वो इन्फिनिट लूप पर जा सकता है if your productions are your left recursive production. अगर आपकी production left recursive है then the compiler might go to a infinite loop. But if your production is a right recursive production, in that case, first of all we use a termination conditions in the program. So it is just like you're using a termination condition first and then you are giving a recursion. So when the compiler uses, they are more comfortable with the right recursive productions, they are not comfortable with the left recursive production. So even though in a grammar you can have both right recursive productions and left recursive productions, but what I want is I want to remove left recursion from the productions. So this is something that we will be studying later on also. तो उसको हम बाद में study करेंगे. So as you are saying mixed recursion, so mixed recursion can also be there, but this is something that we will be studying later on. इतना clear आप सभी को? Is this much clear till now? Any doubt so far? Good. Now so far because we have covered what are the types of grammar, तो हम लोगों ने types of grammar को cover कर लिया है. Now our next step will be to understand that how can we, create grammars for different languages. हम अलग अलग languages के लिए grammar कैसे create कर सकते हैं. So I can write some of the languages here and you can write grammars for them. So I'll take some of the languages. So the first language here is a raised to power n, b raised to power n, such that n is greater than or equal to 1. Okay. Then we have a language, at least two we have done. We have a language which is starting and ending with same symbol. Then we have a language which is starting and ending with different symbols. Then we have a language where the number of A's are even as well as the number of B's are also even. So we can have a language which is WR such that W belongs to A comma B star. Correct? We can also have A comma B plus. So if it is a plus, then it will be a different case. Then we can have palindrome strings. We can create a grammar for this if we have palindrome strings in the language. Let me take more examples here. Let us suppose the language is a raised to power n, b raised to power m, such that n comma m is greater than or equal to 1. We can have a language which is a raised to power n, b raised to power m, c raised to power n, c raised to power k, such that n comma m comma k is greater than or equal to 1. Okay, so we can also have a language which is a raised to power n, b raised to power n, c raised to power m, such that n comma m is greater than or equal to 1. So we can have a language which is a raised to power n, b raised to power m, c raised to power n, such that n comma m is greater than or equal to 1. Okay, or so we can also have a language which is a raised to power n, b raised to power 2n, such that n is greater than or equal to 1. For this also we can create a grammar, and I can take more languages. I can take languages a raised to power n, b raised to power n, c raised to power m, d raised to power m, such that n comma m is greater than or equal to 1. I hope this much is visible. Agar ye visible nahi hai, so I can take more examples later on. Okay, so let us write grammars for these examples. We'll be writing grammars for them. So the first example is number of A should be equal to the number of B, but again in the beginning we should get only A, and then end we should get only B. So here the grammar will look something like this. S can derive A. See, for this grammar you cannot give a regular expression. Is language ke liye you cannot give a regular expression. Why you cannot give a regular expression? Because this language is not regular. Remember this point, it is very important. You will be able to give regular expressions only for regular languages. If your language is not regular, then you cannot give a regular expression for this. Now, because we already know that this language is not regular, hence you cannot give a regular expression for this language. Now, you can say S can derive ASB slash AB. That's it. So this is the grammar for this given language. इस language के लिए हमारे पास ये grammar होंगे which is ASB slash AB. If it is n is greater than or equal to 0, अगर यहाँ पर greater than equal to 0 होता, in that case I will replace this AB with epsilon. तो उस केस में ये वाला जो AB होगा इसके जगह पर we can write epsilon. Now this language here, now it is a regular language. We have already seen the example of this. This is a regular language. Hence, you can give a regular expression for this. It is starting and ending with same symbol. Next one is starting and ending with different symbol. So for this one, it is A plus B whole star, B plus B, A plus B whole star, A. And for the first case, it is going to be A plus B whole star, A plus B, A plus B whole star, B plus small a plus small b, because single a and single b can also be there in the first language. Okay, so let me write the grammar for the second one first, and then I'll write grammar for the first one. So here what you can do is, when I say we have a plus b whole star, I can take it with capital A. So I can say it is S can derive a capital A B or B capital A. Correct? Now I can give the definition of A. So I can say A is AA slash BA slash epsilon. That's it. So we have already seen how can you generate this one. आप इसको देख चुके हैं. We've already seen this one. So I am just using it as a shortcut. तो इसको मैं directly shortcut की तरह use कर रहा हूँ. So if you this first one, so this first one can also be modified in the same way. I can say S can derive A capital AA slash B capital AB slash small a slash small b, where A can generate AA slash BA slash epsilon. So this is the grammar for the first one. इतना clear है सबको? Is it clear with all of you? Any doubt so far? Is there any doubt so far? No doubts, right? Now in the same way you can generate a grammar for this, but here the fact is this is not a regular language. ये जो language है regular नहीं है. This language is basically your context free language, because for this language you can create a push down automata. You cannot create a finite automata, but you can create a push down automata. Now here w dot wr, we have a string and we have a reverse of a string. So when you take wr, it means your if I said w is ab B A, then WR will also become AB BA. So if you take this string which is WWR, so that means it is AB BA AB BA. So here these symbols should match. So basically whenever I'm going to produce a symbol, I should produce it in a combination. So in this case I can say S can derive A as A, because on the left hand side if you are going to generate a, then on the right hand side also you have to generate a. Or it is B as B, because on the left hand side you can generate a, on the right hand side you can also generate a. Or it is epsilon, because epsilon is also present in the language. Here we have a plus b star, so epsilon is also present in the language. So that is why it is this language, which is A as A slash B as B slash epsilon. So on the left hand side if you generate a in a string, if on the left hand side you are generating a, then on the right hand side also you can generate a. So it is WWR. Now what is the difference between in this language? In this language, if this is a language X, this is a language Y. So what is the difference between language X and Y? X और Y के बीच में difference क्या है? What is the difference between both of them? Difference between a language X and language Y. So in language X, we have WWR such that W belongs to A comma A plus B star, right? But in case of language Y, we can have WWR union WAWR union WBWR such that W belongs to A comma B star, right? So what does it mean? Whenever we have a palindrome, so we can have different kinds of palindrome. We can have a palindrome like we have NITIN, Nitin. So even if you read on the left hand side or on the right hand side, the word is same. So here we have an extra word which is T. If we have word which is Malayalam, MALAYALAM, Malayalam. So even if you read from the left hand side or even if you read from the right hand side, this spelling is same. So this is also a palindrome. So if in the same way, if we have a word like ABBA, so this is also a palindrome. This is representing W, this is representing WR. Even if you have a word like ABABA, again it is a palindrome. This is representing W, this is representing WR, and this is a special character A. In the same way, if we have ABBBA, again it is a palindrome. So this is W, this is your WR, and this is your character B. So you can create palindromes in these cases. So there are many palindromes are possible. So for what I can do is, when I create a grammar like this, I can take care of these palindromic strings. I have to take care of all of them. I have to take care of this case, I have to take care of this case, as well as I have to take care of this case. So I have to take care of all of these cases. इतना clear है सबको? Is it clear to all of you? So what I can do here is, it's very easy to create a grammar for this. So you will see the grammar. The grammar is S can derive A as A, because on the left hand side if you produce a, then on the right hand side also you have to produce a. Or it is B as B. On the left hand side you have to produce a, on the right hand side also you have to produce a. Let us assume in the palindromic strings, the minimum length is 1. The length of string is greater than or equal to 1. In that case, I can also replace this s by small a, or I can replace by small b. That's it. This is a grammar which will generate all these palindromic strings. तो इस ग्रामर से जितनी भी palindromic strings है, you can generate all of them. Good. So there's a small difference here. If you try to understand the difference between WWR and palindrome, this is the difference. That in WWR is also a part of palindrome, but when you create a grammar, so the only difference here in the grammar is here we can have slash a and slash b, but in this case you cannot have slash a and slash b. Good? Good enough? You guys are moving towards greatness. I can feel it. Because आपको सब कुछ समझ में आ रहा है, so you guys are moving towards greatness. अच्छा, tell me, how many of you are happy right now? How many of you are happy when you are studying? Write in the chat window if you are happy or not. Then I'll tell you something which one of my teacher told me when I was preparing for competitive exam. So when I'm asking you happy, I'm asking you, are you internally happy or you are outwardly happy? I mean, आप internally happy हैं या बाहर से happy हैं? Why I'm saying this is, so Pratibha, why I'm saying this is that one of my teachers said, when you are studying or when you are preparing something, you will only be able to focus and you will only be able to study if you are internally happy. अगर आप अंदर से खुश हैं, then only you will be able to focus, you will be able to complete your task, you will be able to study. But if you are not happy, if you are sad because of any reason, it can be any reason, external reason, internal reasons, anything. If you are sad, that you will not be able to study, you will not be able to focus. So to be able to focus and to be able to study, you have to be internally happy. आपको अंदर से खुश होना पड़ेगा. So if you look at the toppers of any examination whatsoever, it can be any exam, GATE, IIT, JEE, SSC, or any exam whatsoever, toppers of every exam, most of the people, 99.99% of those people, they are internally happy. They are always smiling in every situation. They always find something positive in every situation. So because they always find something positive in every situation, that is why they are able to concentrate more on studies. They are able to concentrate more on their work, right? So if I ask you whether you are happy or not, I'm literally want to ask you, are you internally happy? क्या आप अंदर से खुश? If your face is very sad and you are not happy, you are angry, then people will start to go away from you. सभी लोग आपसे दूर जाने की करेंगे. They can only come towards you if they feel that, okay. Find a happiness, find a reason of happiness in your life. If you can find a reason for happiness in your life, you can achieve a lot of things. So here, this language is a raised to power n, b raised to power m, such that n comma m is greater than or equal to 1. So here a and b, they are not basically equivalent, correct? So they are greater than or equal to 1. So I can say, S can derive a, b, where a can generate these a's recursively. So you can say a can generate a slash a, and b can generate a b slash b. So this is the grammar for this language. In the same way, for this language also you can give a similar kind of grammar. You can say S can derive a, b and c, where a can derive a slash a, b can derive bb slash b, and c can derive cc slash c. So this is how you can generate for this, right? Now I believe I don't have to tell you this. ये जो आपके पास हैं, these 4 problems, take it as a homework. Try to generate grammars for them, take it as a homework and try to understand these problems. इतना clear है आप सभी के लिए? So take these problems as a homework and try to create grammars for them. ठीक है? Good. Now this was the first session here. We had an introduction regarding the grammars कि grammars होती क्या है. We have seen how can you create grammars for some of the languages. I have not given you a lot of languages. Why I have not given you a lot of languages is because I'm going to take more examples. अभी बहुत सारे examples है. We have to see lot of operations. We have to see CYK. We have to see lot of things regarding the grammars. तो अभी जो upcoming classes में है, we will be discussing more things regarding the grammar. So I'm not taking more examples right now. So in the first session here today was just for the introduction of grammar. What is a grammar and how can you create strings using the grammar? How can you create some basic grammars? Now you can also try and solve previous year question based on the grammars. बाकी भी grammars में और भी चीजें आएंगी. I'm going to cover a lot of things today. So you can try and create a lot of different strings to the grammar. So we'll take a break now and I'll update the timing of the next session in the Telegram group. जो भी अगला session होगा उसकी timing जो है मैं आपको Telegram group में update कर दूंगा. And then again we'll come back. ठीक है? You can have a tea break or lunch break or something, anything you want, and then we will continue in some time. Clear है सबको? So the first session was approximately of 2 hours. आपका जो पहला session था लगभग वो 2 घंटे का था. And then after break we'll continue the next session. ठीक है? So जल्दी से सभी वीडियो को लाइक कर दीजिए और मैं उसके बाद फिर से आपसे मिलता हूँ after a break.